Okay. Okay, semua dah ada. Okey, selamat pagi. Online boleh dengar ke?
Dengar, Doktor.
Baik, terima kasih. Okay, so I'm going to start now. Assalamualaikum, selamat pagi, good morning. For those online, screen nampak? Boleh nampak slide tak? Alright. Okay. So this is lecture number 5. Apa kita dah belajar setakat ni? What have we learned up to now? Sediment, right? It's just broken up older rock material. The source was older rock that's been weathered. We've learned about weathering. There's chemical weathering, there's physical weathering, right? Okay. And then all that material needs to be transported, right? And then it is redeposited somewhere else. We've learned also that if you bury sediment, kaya benam sediment tu, if you bury sediment for a long time, bury in a depth, it can change its chemistry, its mineralogy, its physical properties. That process is called diagenesis, right? Now, the two processes, the two diagenetic processes, which are very important in order to form rock, to transform sediments into sedimentary rock. The process of turning sediments to sedimentary rock is called lithification. Yeah, kita belajar tu. Right. Two processes are important. One is compaction. Right? One is compaction. Yeah. Okay. One is compaction, then the other is cementation. Alright, dua tu. So hari ni I want to reverse a little bit. I go to the process of sediment transport in the middle. So I'm not talking about weathering. We talk about weathering. We've talked about lithification. But what about the process in the middle? This is sediment transport and sediment movement. Okay. So let's have a look at the process of sediment transport and sediment movement. Okay, so back to sediment transport and sediment movement. Okay. The erosion of rocks and the transport and deposition of sediment is governed by physics. It's governed by physical laws. Okay. Transport and deposition of sediment is through physical agents such as wind, water, ice, and gravity. In order to understand the process of sedimentary rock formation, we need to know the properties and mechanisms by which fluids erode, transport, and deposit sediment. Okay? So for example here, I have an environment, my sedimentary environment. I have physical processes operating. I have wind, uh, and the wind is moving the water in the form of waves. Okay, and the water is my medium, my agent of transport. It is moving the sediment. In this case, I have sand. Okay? So I have an agent of transport. I have deposits, and the sand is being transported. Yeah? They're the diangkut. All right. So, why study these processes? Kenapa kita nak belajar ni? One, it is just interesting lah, dia menarik. Some of you who know about geology early on, kan, probably see t-shirts kita, the present is the key to the past and so on, kan. And you learn things about macam dinosaurs ke, comet impacts, climate change and so on, kan. You know, all those stories, when people say cakap pasal ice age, mass extinction, climate change, sea level fall, these kinds of things, all that story, bukti dia, the evidence is mostly coming from sediments, okay? Sediments and sedimentary rock, okay? So if you know, if you understand how sediments are moved, how physical processes interact with sediments, how it changes to sedimentary rock, you can go to an outcrop of very ancient rock, and if you I can understand its textural properties ke, its chemistry ke, you can actually interpret the story macam mana asal dia, ya? Lebih tafsir. So yeah, understanding transport and deposition processes enables the interpretation of what we call sedimentary structures preserved in ancient rocks. For example here, another photo, this is from Brunei Bay. This is near to the border with between Malaysia and Brunei. It's a nice tidal flat there, right? You see lots of ripples, right? Sand ripples, kesan riak, okay? Now, the sand has been transported, has been moved, okay? Has been transported by an agent of transport. In this case, it is water. Air itu yang gerakkan dia, okay? And because of the movement of the water, you get this nice structure that we call ripples, right? Okay. This is modern day. My friend there is in near an earth quarry, quarry tanah. Okay, it's in an earth quarry. It is near to Lawas, also near to the border with Brunei. Okay, it's in Sarawak. Yeah? And you have a sandstone bed there, right? It's a sandstone layer, but it's not like this, not horizontal. It's now dipping, something like 40 degrees. Okay, it's dipping. Okay. Now, my friend here is looking at ripples on the top of a sandstone bed. Those are ripples there. Exactly the same as those, right? But those are 20 million years old, okay? And they have been deformed by tectonics, okay? But we can say 20 million years ago, in Lawas, which is now an earth quarry, there was water moving. Okay, so that's how we come up with interpretations. And that's why we need to understand how sediment is transported. Yeah, I need to move from people getting into the group. Okay, back to this. All right. So that one, you know, the definition for soil. The soil is transported, right, and deposited. What kind of medium, what kind of media can transport sediment? These are the main agents of transport. Agent transport you perlu tahu, this you need to know. Water is the most important agent of transport. Air can also transport sediment. Ice can also transport sediment. Right. The agent of transport tends to be a fluid. Tends to be a fluid. I provide the definition of the fluid, but everybody knows what the fluid is from secondary school physics. So that's the definition. Right. So here I have several images. I have photos of a river, and the river has fast flowing water. This is fast flowing water, right? And notice in the middle, you have these mounds of sand here, sand and gravel. We call them bars in geology, right? So there are mounds of sand and gravel there, right? And the agent of transport is the river water. Okay, the water is moving from the top to the bottom, right? From north to south. Okay. On the right hand side, this photo here, those are large structures that we call dunes. Yeah? You know the movie Dune, yeah? It's in the desert, right? Also in the Middle East, you get the dunes here. Right. So notice the scale there. That is 500 meters at the bottom. So these are big structures, right? And they are made up of very fine grained, well sorted sand, and also well rounded sand. Okay. So it has not been moved by water. It has been moved by wind. So wind is the agent of transport here. Okay. But that's not a photo of the Earth. That is from Mars, daripada planet Mari. Yeah? Because on Mars, you don't have any running water. Tak ada air yang mengalir. So the main agent of transport on Mars is wind. Okay. So wind, water, ice can also be an agent of transport. That is the glacier. You have a glacier at the bottom there. Notice the color of the glacier at the front. It is very dirty, right? There's a lot of sediment inside it. Okay. And the glacier is actually moving, dia bergerak, but very slowly. Okay, but it is still moving. So ice can also be an agent of transport. Okay. So in order to transport sediment, you need an agent. And these are the main agents: water, air, ice. Okay, so remember that. But in our world, dan dunia kita ni, water is the most important one, right? Okay, because you have rivers, you have lakes, and you have seas. So we need to know a little bit about how fluids behave, how water behaves. So water is a fluid, and fluids can flow in two ways. Dia boleh mengalir dalam dua cara. One is what we call laminar flow, okay, where fluid moves parallel to the boundaries containing the flow. What is meant by that? Let's say I have a pipe, right, and I move water through it. Okay. So let's say I put some dye into the water. Kita letak pewarna dalam water, kan? Okay. So what you see is that the water moves in straight line. So you can imagine water particles are moving in straight lines, but you cannot really see them, right? Okay. So this is laminar flow. Okay. So that's laminar flow. Dia tak bercampur. Right? But in other cases, you have what is called turbulent flow. If you imagine the flow of a river, that is turbulent flow. Okay. So in turbulent flow, what happens is that the water particles are moving everywhere, right? So it gets a nice mixture of the water particles, right? So the fluid in the turbulent flow moves in complex and constantly changing directions. Air flows turbulently. Turbulent flow is more efficient in training and transporting sediment, right? What does that mean later on? So yeah, you have two ways in which flows, you have two types of flow. One is laminar flow, where the water particles are moving in straight lines, where you have turbulent flow, okay, where all the water particles are moving everywhere. Okay. How do you imagine this? Well, if it is a river, it is usually turbulent flow. If you see smoke, asap, kan? Let's say smoke from a cigarette, let's say, right? So that is turbulent flow, right? About laminar flow, if you've seen a slurry, macam wet cement flowing, that is laminar flow, right? Or a landslide or debris flow, that is laminar flow. Okay. So what's the difference between the two? The main thing controlling is viscosity, kelikatan. If it is less viscous, it tends to be turbulent. It is high viscosity, it is more laminar. Okay. But when we're talking about rivers, it's mostly turbulent. Okay. Okay, so laminar flow is rare in flowing water, absent in moving air, but occurs in high viscosity fluids. Turbulent flow occurs in low viscosity and high viscosity, high velocity flows. Okay. Most flows in water and air that are likely to carry significant volumes of sediment are turbulent. So dealing with water and air, it is mostly turbulent. Okay. So in this class, I'll just talk more about turbulent. The main point is this: you have two types of flow. There's turbulent, there's laminar. That is what you need to know for this class. Okay. All right. So you have water, and water is moving. Right. Let's say you have a river, and the water is moving from the left to the right. Okay. And the water. So let's say we can see a cross section of the river flow. Maybe it's a water tank, right? And it's transparent here, right? Okay. And this is the riverbed. And then you have water moving from the left to the right. Now, let's say we have sediment at the base of the bed here. Okay? The bed here, right? It's sediment. So made up of lots and lots of grains. Okay? So the water, because of friction, will interact with the grain. Okay? It's what pergeseran saja. Okay? And because of that interaction, because of that friction, the grains start to move. Dia mula bergerak. Okay? How do they move? They move in two ways. Dua cara. This one you need to know also. There's suspended load and also bed load. Okay? Now, suspended load and bed load. Suspended, so meaning in suspension, terampai. Okay? In the case of suspended load, movement is not in substantially continuous contact with the bed. So it is floating. The yellow grains here, these are your grains of sediment. Okay? And they are not in contact with what we call the bed, the bottom. Always floating. So that is suspended load. Alright? But if your grains most of the time are in contact with the bed, we call it bed load. Okay? So the suspended load, we have bed load. Alright? So movement in substantially continuous contact with the bed. Okay? And under bed load can divide into two types. One is rolling and sliding, and also what we call saltation. So suspended load and bed load. Under bed load, you have rolling, sliding, and also saltation. Okay. You see where I'm going here. Okay. We'll go back here. Easier to tell a story. So bed load, most of the time the grain is in contact with the bed. Okay. So rolling and sliding is very simple, right? If you have a pebble here, there's a roll, right? Golek, so that is rolling. Okay. So most of the time it is touching the bed. Sliding also the same thing. It just moves but does not roll, right? Okay, so that's sliding. Saltation is when the grains are jumping. The lompat. Basically, it is flying. Basically, the saltation is flying. It follows the trajectory. There's friction, and the grains jump, but eventually they fall down. They follow a ballistic trajectory. Okay? So that is saltation. And I think I want to stop here first. It's better to show a video in order to understand it. Try to find a nice video to show. Okay, this might, okay, this is a very short video. You can see a few things. Sorry for those online, I can give you the link later on. So what we have here is a bed of sediment at the base, and then I have water moving on top. All right? And I can describe the sediment below in terms of texture. There's sand of different grain sizes. There's also pebbles inside it, right? We have gravel also there. Right. The sorting is relatively poor sorting. The grains, they are angular to subangular. So I'm describing the sediment. Right? Okay. Let's see how the sediments are being moved, being transported. The agent of transport here is water. Okay, water is moving the sediment. Okay, so you see a few things. Some of the grains are just moving through bed load. There's a lot of bed load transport here. You see a lot of rolling and sliding. Most of it is rolling and sliding. Some of it is rolling, some of it is sliding, right? These are waves, so it goes left and right. But notice also, these finer grains are actually jumping, right? They go up because of the water moving, then they fall down eventually, all right? So you have both sliding, rolling, and also saltation, okay? You also have saltation there. But notice the water above here, I-O, right? There's very murky water here, it's turbid, right? So that is suspension. You have the suspension there also. The grains are not in contact. Okay, so the coarsest grains are experiencing bed load. Okay, you have bed load transport here. You're sliding, you're also rolling. Okay, but you also have the finer grains are actually jumping. There's flotation also. Right, but the finest particles, the clay size and silt size particles, are floating. They are in suspension. That is suspended load. So you have bed load and also suspended load in this case. Get it? Okay. Okay, so let's run the video one last time just to appreciate the processes. Because visually you can easy to understand it. So yeah, sliding and rolling, jumping of the smaller particles. That's jumping. That's saltation, and then the murky water above it, the turbid water, is suspension. Okay, you have all that together. Okay. Then going back to the slides. Okay. Okay, so going back to this. All right, so you have bed load, you have suspended load. Okay, and the bed load you can have simple rolling or sliding, or you can also have saltation, right? So what is rolling? Rolling grains are moved due to frictional drag between the flow and the grain. Okay, further force is needed to make grains salted. Okay, in order for the grains to jump, you need to have the Bernoulli principle. Okay, so what happens is that you have the grain here. Let's see if I remember well how to do it. You have the grain here, and then you have a flow above it. Where it flows above it, the grain here in this case you have irregularities. The surface goes up and down. Okay, so you have cases which have higher elevation. Right? So what happens when you have a water flow above it here? Above the grain, the water moves faster. Right? Moves faster, you get lower pressure. So just like you learn in school, the Bernoulli principle, you have high pressure above, below it, the grains just jump, they move upwards. Okay? It flies basically. Right? But eventually, as it loses energy, it falls down again. Okay? So that is how grains jump. Okay? So velocity over the grain will be greater than the upstream and downstream of it. There's a reduction in pressure above the grain. Reduction in the pressure provides temporary lift. Okay, so you naik ke atas, and this moves the class of the bottom, that moves the class at the bottom of the flow. The class is grain, basically, yeah. The grain is temporarily entrained in the moving fluid, but eventually it falls down again. Okay, so that is saltation. Okay, it's just jumping of the grains because of changes in pressure. Okay, so those are the three ways in which grains can move. First, you have suspension. A lot of the time, suspension happens when you have very fine grains. Okay, most of the time it is usually silt or clay in suspension. Okay, so in this case, yeah, you have very small grains, very fine grains. The grains are lifted off the bottom and into a higher velocity turbulent flow. Saltations usually happen when you have coarser grains. The mass is large enough to overcome the turbulent velocities, so it rises, but it needs to fall down again. Yes, yeah. It's still still too heavy, right? But when it falls down, it contacts with other sediment, and the other sediments also jump. Okay, so you get lots of these grains jumping because of that. All right, and then you have sliding and rolling. Both of them are grouped together in what we call traction. Okay, this usually happens when you have coarser grains, gravels, let's say. So notice if you remember the video, a lot of the rolling grains are usually the gravels. Okay, so yeah, the grains which are too large, upward velocity cannot lift it, and just pushed along the bottom by the current. Okay. All right. So there's a photo. In this case, yeah, I still have sediment. I have sand at the bottom. Right. I have the source of my sediment at the back, which is a hill, right, of older rock material, weathered, and now it's being transported. But in this case, it is not being transported by water. The agent of transport here is air, udara. Okay, so this is what we call an aeolian process. Okay, so wind is also a fluid. All right, okay, it's a fluid. But the difference between wind and water is that the viscosity is much lower. Kurang likat. It's very light. We can move through it very easily, right? Compared to water. Okay. But the flow is still turbulent. It is still turbulent flow. Okay. So what happens in a wind-dominated sedimentary environment? You can have finer grain particles being transported. Most of the time, it is in the form of fine to very fine grain sand, and also silt and clay. Okay, so sediment is being transported here. So you can see along the bed, you see a lot of ripples here, but it's not because of water moving; it's because of air moving, because of wind. It's not udara, the angin, right? So you get traction in the form of rolling and sliding happening here. You also get jumping grains in the form of saltation. Okay? But notice the air is very dusty, right? So this is the finer grain fraction. The clay-sized particles and the silt-sized particles, they are moving through the process of suspension. So you have bed load and also suspended load, but the agent of transport here is not water, it is air. Okay. So as a recap, you have sediment transport, right? Okay. So it is an element of how sediments are formed before deposition, right? In order for sediment to be transported, you need to have an agent of transport, and the agent of transport must be a fluid. It can be water, it can be air, it can also be ice. Okay. But the main agent of transport is water. Water is the most important. Water is viscous enough to move coarser grain material, right? And it can move very fast. You can have lots of places where you get water moving, like the ocean, like in lakes, like in rivers, right? Okay. So it's main agent of transport, but it doesn't have to be the main one. If you go to a desert, wind is going to be the main agent of transport, right? If you go to a very cold climate area, glaciers can also transport sediment. Okay, ice can also transport sediment. So yeah, and then if you have an agent of transport and sediment is being transported, there are two ways in which sediment can be transported. You have suspended load, where the sediment most of the time is not in contact with the bed. Okay, so that's suspended load. And then you have bed load, where a lot of the time the grains are in contact with the bed. Okay, now, and under bed load, we learned that there are two types of bed load. There's rolling and sliding, right? Okay, so that's because of traction. And the next one, you also have the grains jumping, that is saltation. Okay, so those things you need to know. I'm just telling you what is important for things for evaluation, right? So you need to know those. Another tip, try to draw the diagram. Okay, easier to understand when you draw the diagram. Right? Okay, so sediments can be moved by an agent of transport. That's what we've learned about. All right. But I want to introduce you to another thing. This is Stokes' law. Stokes' law of settling. We've learned this also in Asasi in secondary school in STPM. This one has already covered. Probably you've seen, remember the experiment where you have a water column. This, and then you fill it in. But usually you can use any kind of fluid. Main thing is that you know the density of the fluid. Right? And you put in grains in the different diameters, right? So these things have the same density, right? So they have the same density. We put it inside the water column. We play around with the size. Some of the ball bearings are smaller. Some of the ball bearings are larger. All right. So, which one will fall down first? The bigger ones or the smaller ones? The bigger ones. Where is Stokes' law? Right? So, Stokes' law of settling. It is the theory of the velocity of small grains settling through a fluid. Okay. So that's the equation. I'm not going to ask you about the equation in this first year course. Right. Just need to know it. So the velocity of the settling depends on several things, several parameters. The density, of course. Right. You know the density of the fluid, the gravitational acceleration, the viscosity of the fluid, and also the grain diameter. Okay? So in this case, I know the density of my material. Semua ball bearing sama je kan? The density is constant. My fluid density is also constant. I don't change it. Gravity, of course, doesn't change, right? It's a constant. The viscosity of the fluid also I don't change. So the only thing that's going to matter is the grain, the size of the grain. Okay? So the settling velocity of a grain is dependent on the grain diameter. If the other factors are constant, so larger grains settle faster than smaller grains. Okay, so that's another rule you need to know. Okay, so eventually these things will fall down. You get a layer of sediment forming. But you notice that the coarsest grains are at the bottom, and the grains become finer as you move further upwards. Okay. And in sediments, you tend to see this. Why does this happen? Because it's just falling down from suspension. Right? So this is suspension. Okay. So you have a body of water, and then a lot of sediment is dumped into the water, and they are of different sizes. The coarsest will fall down first. Right. Okay. So you get this nice layer which grades upward, we say, from coarse to fine. That is very typical. That's because of Stokes' law. But another thing that happens is when you have water moving. And you get an interaction between the sediments and the grains. Okay? So let's see what happens. I need to draw this. So I have a body of water. And the water is moving from the left to right. and I can control the velocity. The water is coming here. I put that. And then I have water, and then I also have sediment, right? I have coarser grains, I have finer grains. All mixed together, right? Let's say I start with a very fast flow. Let's say, for example, my water is moving 100 centimeters per second. 1 meter per second. Moving, okay? So it's moving as it's moving. But then let's say we can control the flow velocity. Kita slowkan air tu. Okay? So what you start to see is that as you decrease the flow velocity, all this is just moving down. The coarsest grains will fall down first. Okay? The finer grains are still moving. Right. So let's say this is up 0.5 meters per second. The slow down. Tapi when we further slow down the water movement, kita kurangkan lagi power PV kita tu. So what happens is that these finer grains start to fall down also. Right. And then you further reduce the flow velocity, the finest grain fractions will fall down. Okay? So, this is what they found out. There is a relationship between how fast your flow is moving and the grains that can be deposited. Okay? So, you have this guy doing an experiment. This is what is called the Hillstrom diagram. Nama orang tu yang buat eksperimen ni Hillstrom. So, what he did is what? The same thing. He had a water tank. He dumped a lot of different kinds of grain sizes into the water tank and he played around with the flow velocity. Okay, so you get this kind of curve. So this graph here is grain size versus flow velocity. So going from clay to boulder, getting coarser on that side. Going from slow 0.1 centimeters per second to 1,000 centimeters per second. Getting faster. Let's move further upward. Alright? So this is the relationship for deposition. Notice the red curve here. Okay. So notice what happens. High flow velocities, only the cobbles fall down. Further reduce the flow velocity to 10 centimeters per second. Now only can the granules and very coarse sand fall down. Yeah. And then further reduce the velocity, you start getting the very fine sand and also the silt falling down. Okay? So that's the relationship between flow velocity and particles which are being transported, already in motion, you say, right? So, for a given grain size, grains already in motion will be deposited as velocity decreases to a certain point. Okay? Okay. At low current velocities, only the fine particles are kept in suspension. At higher flows in water, all silt and some sand may be kept in suspension. Granules and fine pebbles, they are saltating, and the coarser material is rolling. Okay? So that is the curve and shows you the relationship between flow velocity and grain size, okay, and when it becomes deposited. But that is when that is when grains are already moving. Dia sudah bergerak kan. Bagaimana pula if you start where the grains are stationary, duduk diam, dia tak bergerak lagi, it forms a bed at the bottom. So start like this, and you play around with the flow velocity. And the relationship is the other way around. Okay? Slow flow velocities, you're going to only get fine sand being transported. Alright? When you make the flow stronger, the coarser sands start to get transported. Stronger flow, you get the gravel start to move. Okay kan? Kalau you bayangkan kalau dasar sungai, arus dia lemah, yang bongkang-bongkang besar tak akan bergerak kan? That's the main point lah, right? Okay, so it's very common sense, right? So that is what you get, and in the upper curve, and that is tells you transportation. That's the upper curve. Okay. So sediments at rest, but once you reach a certain flow velocity, in this case, 20 centimeters per second, your sand starts to move. But you need to have a higher flow velocity in order to get your cobbles and pebbles to move. Right? So you have to press the switch. So it works you get a really nice curve here forming. But notice, you need to have higher energy in order to move compared to transport. Okay? Di atas lagi kan? Have higher energy. Okay? You need extra energy if you want to move sediment which is stationary, which is at rest. Okay? And another thing you need to remember is this. Notice the curve on the left. It doesn't follow that pattern, right? It seems that you need to have the same velocity to move pebbles in order to move silt and clay. So that is a little bit apa? Dia macam counterintuitive. Kawan sikit dia hukum. Logically, you should say that the clays you just need just very slow movement in order for the sediment to be transported, right? So what is happening? You've played with mud before, right? You have electrostatic charges between clay particles, all right? So they tend to clot. They stick together, okay? They are very cohesive, we say, all right? Right? When you're trying to clean your tires, which are very muddy, it's very hard to erode, right? Hard to clean, right? Okay, so yeah, clays are very cohesive. They are harder to erode. So that's why you need to have higher flow velocities in order to transport silt and also clay. So it's the other way around. So the rule only applies for grains which are coarser than silt from sand up to boulder, right? As you increase the flow velocity, coarser and coarser grains will start to be transported. Okay. Okay. I'll stop there. Oh. You mean for here? On the red line? Oh, okay, not as I said, start here, right? Okay, so this is for deposition, right? In order for the case to for the sediment to fall down. Alright? So boulders, granules, very fine sand are easy to form there. If you're moving, you just reduce the flow velocity, they will directly be deposited. Clays are a little bit different. They are so small, they are so light, very light. So even though the velocity is zero, it's still floating. Right. Observations in real environments, in the oceans, let's say, a clay-sized particle can remain in suspension for several months. It's too light, right? But eventually it will fall down. It takes a long time. Okay. So it's just want to show that it's not going to directly deposit. Okay. So any other questions? Okay, in that case, we'll continue on Wednesday, but I believe ramai tak ada kot on Wednesday. So do you want to do it physically or not? Do you want to do it physically? Oh, you're not going? Okay, all right. I'll be here, no problem. Okay, so yeah, so we do a hybrid then. So some of you might be traveling for holidays. All right, so see you on Wednesday.
Doktor,
Alamak. Ya.
doktor,
Ya, saya.
nak tanya kalau attendance macam mana ya?
Nanti saya buka kat Spectrum.
Okay. Terima kasih.
Thank you, doktor.
Sama.
Thank you, doktor.